Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces.
Today, we're looking at a fascinating paper with a pretty long title. AI-guided digital intervention with physiological monitoring reduces intrusive memories after experimental trauma.
Whoa, that's a mouthful. Let's translate that into plain English. Essentially, researchers are asking, can we use an AI chatbot, a video game, and an eye tracker to help people deal with traumatic memories?
Exactly. And to understand why this is so important, we need to talk about trauma. Unfortunately, most people, around 70% globally, will experience a traumatic event at some point in their lives.
And for some, this can lead to conditions like post-traumatic stress disorder, or PTSD. One of the most difficult symptoms of PTSD is having intrusive memories. These are like unwanted flashbacks, vivid, distressing images or sensations from the traumatic event that just pop into your head without warning.
These memories are a huge source of distress, and they're a core part of why trauma can be so debilitating. Now, we have good psychological treatments for this, but they usually require multiple sessions with a highly trained therapist.
And there's the bottleneck. There just aren't enough therapists to help everyone who needs it. So the big question researchers are trying to answer is, how can we make effective treatments more scalable, meaning available to many more people?
This is where today's paper comes in. It tests a system called antidote. The name is an acronym, of course, but think of it as a potential antidote for these intrusive memories. It's based on an existing treatment called the Imagery Competing Task Intervention, or ICTI.
Okay, let's break down ICTI. It's a really clever idea. The therapy has two main steps. First, you briefly reactivate the traumatic memory. You just bring it to mind for a moment.
And right after that, you do something that completely hijacks the visual part of your brain. In this case, and in many previous studies, that something is playing a visually demanding puzzle game. Think Tetris. Your brain gets so busy rotating shapes and planning where they'll go that it doesn't have the resources to properly resave or reconsolidate that intrusive memory.
It's like you're trying to save a big video file, but then you immediately start playing a high-def movie. The system gets overloaded, and the original file gets corrupted. In this case, that's a good thing. The intrusive memory becomes less vivid and happens less often. The problem is, this usually requires a human guide to walk you through it.
Right, so the researchers behind Antidote wanted to see if they could automate the whole process. They replaced the human guide with two things: a generative AI chatbot and physiological monitoring.
The AI chatbot acts as the instructor. It's a text-based chat that explains what you need to do at each step of the experiment, and even checks that you've understood the instructions.
And the physiological monitoring? That's where the eye tracker comes in. They used a technique called pupillometry.
Pupillometry is just a fancy word for measuring the size of your pupils. It turns out that when your brain is working hard on a task, what scientists call cognitive effort, your pupils get bigger. It's like a little window into how hard you're concentrating.
So how did they test this? They recruited 100 healthy volunteers and had them watch a film made of traumatic video clips. This is a standard, safe way to induce intrusive memories in a lab setting called analog trauma.
After the film, they briefly had everyone recall the most distressing moments. Then, they split them into two groups. The intervention group got to play that Tetris-like block puzzle game for 15 minutes.
The control group, on the other hand, spent 15 minutes doing something that wouldn't use up their visual processing power. They just listened to a podcast about classical music.
And throughout this, the AI chatbot gave instructions and the eye tracker watched their pupils. Afterwards, for the next 7 days, participants had to keep an electronic diary and log every time an intrusive memory from the film popped into their heads.
Okay, the moment of truth. Did it work?
It absolutely did. The group that played the game reported significantly fewer intrusive memories over the next week. We're talking about a 45% reduction compared to the group that listened to the podcast. That's a really solid result.
Wow, so just 15 minutes of playing a game made that much of a difference? What about the AI guide? Was it any good at being an instructor?
It seems so. The researchers had 2 human experts grade the AI's conversations with the participants using a clinical rubric. They found the AI guide was competent and delivered the instructions effectively. Plus, the participants themselves rated the AI guide highly in surveys.
That's amazing. And what about the pupillimetry? What did they find out from tracking people's pupils?
This is where it gets really cool. First, they confirmed that playing the game required a lot of cognitive effort. The pupils of the game-playing group were much larger than the pupils of the podcast-listening group.
So people were definitely concentrating hard on the game.
Exactly. And the more the game difficulty increased, the bigger their pupils got. But here's the most important finding. They found a direct link between this effort and the treatment's success. For the group that played the game, the harder they concentrated, the bigger their pupils were, the fewer intrusive memories they had later.
That's a direct, measurable link between engaging with the treatment and it actually working.
Yes, and they found one more layer to it. The researchers looked at pupil size during 2 key moments, recalling the memory and then playing the game. They found the ideal recipe for success was low cognitive effort when recalling the memory, followed by high cognitive effort when playing the game.
So you don't dwell on the memory, you just activate it, and then you hit it hard with the distracting game.
That's the 1-2 punch. Don't get stuck in the memory, just get to the game and give it your full attention.
This is all incredibly promising. It's a proof of concept showing that a fully automated system can deliver an effective psychological intervention right after a traumatic experience.
And because it's automated, it's scalable. You don't need a trained therapist in the room. This could be a low-cost, accessible tool that could be deployed widely, maybe even in emergency rooms or for first responders.
Of course, this is still early days. It's a lab study, not yet a product you can download on your phone, but it opens up a clear path towards developing new kinds of digital mental health tools that are backed by science.
It's a fantastic example of how new technologies like AI and neuromonitoring aren't just gimmicks, but can be used to make proven treatments more effective and accessible for the millions of people affected by trauma worldwide.
And that's our daily paper for today. Thanks for tuning in.